Welcome to the problem we have today. We are diving into the world of multi-frequency phase unwrapping algorithms using Python 3 in Numpy. We have 7 single-channel grayscale images, each of shape 1080, 1920, stacked along the third axis to form a shape of 1080, 1920, 7. The challenge lies in efficiently solving for each pixel using a shift matrix A of shape 7, 7, in different intensity values represented by array R of shape 1, 7. The goal is to minimize L2 norm using Numpy's lstq function, which traditionally involves nested for loops, but fear not, we have a more efficient solution on the horizon. Let's delve into the solution. We kick things off by reshaping the image array to have a shape of 1080, 1920, 7, and setting up our shift matrix A. By reshaping the image array to 7, 1080 *1920, we are able to leverage Numpy's lstq function to efficiently solve for x, the unknown we seek. Once we have our solution, we reshape it back to the original image shape, and voila, we have optimized our process significantly. Now, let's take a closer look at how we verify the accuracy of our solution. By utilizing np.testing.assert _all, we can confirm that for any valid indices I and j, the obtained x matches the result of np.linalg.lstq applied to A and the specific image pixel at ij. This step ensures the correctness of our calculations and validates the efficiency gains we've achieved through our approach. But wait, there's more to explore in this efficient workflow. We finalize our validation process by asserting that the matrix multiplication of A and X at indices I, j equals the original image pixel at I, j. This step adds an extra layer of verification, guaranteeing that our optimized solution not only minimizes L2 norm, but also accurately reconstructs the original pixel values. And there you have it, a streamlined and effective approach to tackling the multi-frequency phase unwrapping problem with Numpy. In summary, we have successfully optimized the process of solving for each pixel in the multi-frequency phase unwrapping algorithm by leveraging Numpy's efficient vectorize capabilities. By reshaping the image array, applying lstq function, and validating the results, we have streamlined the computation and ensured the accuracy of our solutions. Thank you for joining me today, and remember to subscribe, like, and comment below with your thoughts, maybe even share your favorite programming joke. See you next time.